Recording in progress.
All right, so we're gonna go to the homework first. Guys, quiet, please. Thank you. All right, so I posted the answers to Schoology, so you guys should have access to that. Here we go. Yeah, we're gonna go all in great detail. Yep. So let me pull the blank one first. As much detail as you guys want. All right. Okay. So taking a look at this section here, 4.4. Again, I put the solutions up already. What questions do you guys have? Which ones do you want to ask about? Or do you want to go over one part of each question type? Okay, we'll do that. Okay. So let me do part A. So part A, they give you the coordinates, right? 3, -3. So you're gonna just plot it. So 1, 2, 3, 1, 2, 3. Here we go, right? There's 3, -3. What I would do is I draw a right triangle like this. So you're gonna deliberately draw a hypotenuse from the origin to the point that you're told, right? To the point 3, -3. And I'll probably redraw a triangle off to the side here. What are the dimensions? How long is each leg? Based upon the coordinates and what I see in the coordinate plane. 3, 3, right? But I know it's kind of weird, but I'll make the vertical side -3 because point that. Naturally, if I have a size point, so I have to make that negative also. Those points are pointing up, make positive. Okay, the hypotenuse. We'll call this R, because that is the radius, right? Because if you were to draw a circle, it would look like this, right? It's a crappy looking circle, but just go with it, right? So how long is that radius? How would I determine that radius? Yeah, you do Pythagorean theorem. If you do it correctly, you should get √18 or 3√2. You don't have to simplify it, but it just might make the math a little cleaner. And you guys should know how to simplify radicals. Just find a factor of 18 as a perfect square, pull it out, right? So it's 3√2. Okay, so that's 3√2. So I'm going to replace that now with 3√2. At this point, what you're doing is you're doing y over r, x over r, and y over x for sine theta, cos theta, and tan theta. And you're going to flip all of them to get the cosecant, secant, and cotan. So what is our y coordinate here? Obviously, it's -3, right? What's our r value? 3√2. It reduces -1 over √2. What's your x coordinate? 3. What's your r? 3√2. That simplifies 1 over √2. And then what's your y over x? Sorry, it's y over x, my bad. That's just -3 over 3, which of course is -1. So those are the answers. And then you flip them to get the cosecant, secant, and cotan. Pass them, go ahead.
We have, if we leave it like -3 over 3 √2.
That's okay. Don't worry about it.
Okay.
Yeah,
that's
fine.
Right?
It's still valid. Yeah. But that's how you approach these problems, is that plot the point, which I know you guys can do. Do Pythagorean theorem, I know you guys can too. But the one part that may not be very clear is how to draw the triangles. What you do is you take the origin and the point you're given, and you connect those two. Make that hypotenuse. That's your big hypotenuse. And then the legs are going to clearly be on the x or y axis, or parallel to the y axis or parallel to the x axis. Actually, the leg will always be on the x axis. The horizontal leg, the vertical leg, be careful. Yeah, that's all you do. And then, of course, you got to flip these. So cosecant is a reciprocal of sine. That's -√2. -√2. Secant is going to be +√2.
But what is secant like? So secant's opposite of...
Just a reciprocal of cosine. Yeah, just reciprocal of cosine. And cotan is going to be -1. And I think what I'll do, let me talk to Mrs. Sui, because she's the other teacher for the class. Most likely, I'm going to lean towards giving you guys a formula sheet.
Oh, that'd be so fire.
Because we're going to be doing trig all semester. So ultimately, you guys will get to the point where you'll just have this memorized. But because it's still kind of new, we're still, only week 2, roughly. I'm okay maybe for the first test, but maybe the future test we don't do that. Because ultimately, you do want to know these things. Yeah. You move on to the next level, like calculus or whatever you do after this class. Yeah, if I show you the solution key, it's right here. I mean, I just kind of put the answer. I didn't really work up, but it's nice to see the process, right? Like, how do you think through these problems? That's what you do. So you do B and C the same way.
Do you do question 3?
Yeah, totally. Before I do 3, let me do 2. Now I am going to do a check-in. The check-in is going to be kind of like question 2, just to check to make sure unit circle is going okay, because I just want to make sure that's fine. Yeah, so unit circle, if you just pull it up, I'm going to pull it up right now. I don't know, I don't have it here. Should put everything in one folder. One, do I have it here? Awesome, I don't. So let me go to my Algebra 2 honors folder. Here we go. Chapter 13. Select unit circle. Here we go. So what you want to do for unit circle step, if you see that angle, great. Then you're almost done. Do I see pi somewhere? Yeah, I see a pi. See right there, right? So both those coordinates, the coordinates are -1, 0, right? So when I do a problem like this, I'm gonna say, great, I see where pi is. The coordinates are -1, 0. Now the part that it's kind of similar to the previous problem, right? Sine theta is y over r, but r equals 1 on the unit circle, right? That's what we call the unit circle. So we could just deduce that sine theta is just y, but only when you're on the unit circle. Only when you're on the unit circle, which I am, right? So you can do that. Cosine theta, of course, is going to be x over r, tangent y over x, and so forth, right? So I'll put this off to the side here. So cosine theta x over r, tan theta y over x, sine theta y over r. We have all that. And then, of course, you just flip them for the other ones, right? So, yeah. So you want the x coordinate, it's just -1. Done. That's all. So next up, cosecant pi. Same coordinates. Now cosecant, what are you watching? The ballpark? The Giants? Okay. Yeah. Well, Giants suck. I'm like so disappointed in them. They had the chance. Anyway, Boston's not much better though. But anyway.
Yeah, no, they started out strong and they lost that 27-5.
Yeah.
What?
It's a tough division.
They lost 27-5? How is that even possible?
Wait.
The Red Sox won 1 game.
I think
28-5 to Toronto. Yeah, I remember that game. Yeah. Actually, I had a bunch of Blue Jays in my fantasy team, so I was happy about that one. Sorry. Anyway, yeah, that's my guilty pleasure.
How do you like hits?
It's just I'll talk about it later. I need to get to this first. Undefined. Okay. So cosecant, you got those 1 over sine. Okay. But again, that's why I might just do the formula sheet, just so you don't have to worry about. But it's 1 over sine. Also the fact that minus y, we know this, right? This y for on the circle, 1 over 0 is going to be undefined. Or if you want, you could do r over y, but the r is going to be 1 anyway because it's a unit circle. So and y is 0, so you still get the same thing. So that's B. And then lastly, for the other two, 3 pi over 2, look at the unit circle. 3 pi over 2, where are the coordinates there? That's going to be right here. 0, -1.
For CSC, it's not 1 over y.
It is 1 over y, and the y coordinate was 0 there. 1 over 0 is undefined.
Okay.
Right. Yeah, because remember the coordinates were -1, 0. And I did -1 over 0,
Okay.
which is undefined. Yeah. Or actually, sorry, I just did 1 over 0 because I do 1 over y.
And tan is still y over x.
Tan still y over x. Yeah, actually, let me just do this. Tan's y over x. That's x over y.
There's so many to remember.
That's 1 over y, and that's x. There you go.
That was the hardest part, was finding all of the, like, I kept having to write it down on each page to make sure I knew.
The best thing to do is this. When you have unit circle, do that.
Yeah.
SOHCAHTOA. If you do SOHCAHTOA, sine's going to be y over 1.
Yeah.
Cosine's x over 1, and it's y over x. And flip for all the other ones. That's it. So 3 pi over 2 is 0, -1. And you want y over x. Still undefined. Cotangent of pi over 2. That's at 0, 1. Cotangent x over y. So you get 0. So yeah, that's how you do it. Questions about numbers 1 and 2 before we do 3? Okay, number 3. 3 is a little more challenging. There's a little more involved. So you're asked to state what quadrant is and explain your answer. Let me show you the solution key. That might help, because I think I kind of get my reasoning here. Okay, so let's just kind of simmer on this a little bit. Sine. Sine is y over r. We talked about this, right? Cosine x over r. We talked about that. Both are less. Well, sorry, one's less than 0, one's greater than 0. Now r is always going to be positive, because r is the square of x squared plus y squared. So r is always positive, right? So if r is positive, but y over r is less than 0, that's where you have to think more critically, right? If I have a positive number here, so using some numerical analysis, y has to be negative, right? It's got to be negative, because negative by positive 2 less than 0. X over r is positive, r is positive, x is positive. So that we guarantee x over r is greater than 0. Great. X is positive, y is negative. You know the inner circle, sorry, you know the supported plane, that's Q2. Because Q2 x is positive, y is negative. So that's the thinking you use for these problems. Here, tangent's negative, but sine positive. So that's y over x. Well, first of all, sine theta is y over r. R is always positive, so y is positive. If y is positive, x has to be negative. So for that to be less than 0. Probably easier to start with the sine theta. You know r is a positive value. So you have greater than 0. So y is positive, x negative. That's the case for Q4. Lastly, here secant is r over x. It's a flip of cosine, right? Cosine of x over r. So secant will be r over x. That's less than 0. Cotangent of x over y is greater than 0. Since r is positive, but this whole thing is less than 0, x has to be negative. If x is negative, y has to be negative also. For the ratio to be positive, x over y to be greater than 0. If x is negative, y must be negative. Therefore, you get Q.
Wait, sorry. So if y is positive and x is negative, wouldn't that be quadrant 2?
Oh, wait one second.
Damn.
Oh, hold on. Wait, did I make a mistake?
Damn.
Oh my goodness.
Isn't the first?
No wonder you guys are confused. Oh my goodness. I got to fix my escape. I think I got it. Hold on. Wait. Iris, you guys credit.
You get extra credit.
Yeah, no, not that.
Thank you.
No, I'm glad you can see that. It's just.
No, you
No, I'll take
only
it.
I get extra credit.
And you do too, JP. I remember you too. Yeah. Okay, guys. Sorry, my bad.
Is this something that's gonna be like?
I got the X and Y's right. This is when you did it too fast. I'm human.
It's gonna be something that we have to do on the test. Like,
Yeah.
Oh, I'm gonna need the other bill.
Well, that's why you're gonna do the practice test over the weekend. See how you do. Right. My apologies. I mixed them up. I'll update my answer key later today. My apologies. Yeah, I cannot believe I did that. Let's see, make sure I got it here. Yeah, I'll figure it out later. Yeah, I'll make a correction later today, guys. My apologies. Jeez. Okay, let's move on. Okay. So let me walk you guys through the next one. All right. So again, thank you guys for catching that. All right. Question 4. Okay, you're told what quadrant you're in. You're told you're in Q3. So you're going to draw a triangle like this. Now, sine. Is opposite of hypotenuse. I'm going to make this negative 12. And make that 13. Why did I do that? Because if this is your angle, negative 12 is for your opposite angle. And 13 is, of course, the radius. The sine is y over r, right? You know this already. Sine is y over r. Again, why is y over r? Because that's r, that's x, that's y, that's theta. So SOH, y over r. All right, if I do Pythagorean theorem, you should get negative 5. I mean, technically it's 5, right? Side can't be negative. Well, make it negative by some going to the left, right? Whenever you're going to the left, make the horizontal side negative, point down, make the vertical side negative. All right, now, you're asked to find the 5 other trig functions. So I have to find cosine, I have to find tangent, and I gotta do the reciprocals, right? Cosecant, secant, and cotan. Cosine, that's going to be -5 or 13. Tangent, 12/5. Cosecant, flip the sign. Secant, flip the cosine. Cotan, flip the tan. There we go. That's the process. So now what you have to do for B and C, because A, we're explicitly told what we want to look at. That's going to be easy. B and C are not. So you got to figure out, tonight, obviously I messed it up for the previous, so I promise I'll get these correct for B and C. But for part A, does that make sense what I did? Again, I knew it's Q3, so do the triangle correctly. Know that sine is y over r. So r is always positive, make the r 13, make the y -12. The x has to be -5 to do the Pythagorean theorem. Again, you point up, negative, point down, negative, and you just do the rest.
Wait, really quick, I got root 13 when I did the Pythagorean theorem.
For this one?
Yeah.
So you would have x, you have x squared plus -12 squared equals 13 squared. If you do that correctly, x squared should equal 25.
Yeah.
X should be 5.
Wait, why wouldn't you do -12 squared plus 13 or root -3 squared?
Okay, so I wouldn't root just yet because you want to isolate x. So I think what you're telling me is that you probably did something like this. Did you do
No.
that? Okay,
No,
good. But I didn't do that. So then you should have had this if you use a calculator. Then you should have
I did
this.
144 plus 160.
There we go. So this is careless error.
Yeah.
Got it. Okay. All right. So for these guys, tangent is negative. Remember, tangent is y over x. Sine is y over r. R is always positive. That's an x. Sorry. R is always positive, so y is going to be positive. But tangent is negative, so x will be negative. If x is negative, I'll get this right, and y is positive, we're in Q2.
How do you know tan is negative?
Because it equals -2/3.
Oh, I did, okay.
And again, r is always positive, right? R is always positive. So sine is positive, it's greater than 0. Sine is y over r is positive, y is positive. But here, y over x is negative, y is positive, x is negative. Let's see here. So Q2, I've got this. That's -2 and 3. Opposite over J. Nope, I didn't get it. 2 over -3, my bad. Because x is negative, y is positive. And then that's root 13, by the way. Then you just do the rest, right? You do y over r, x over r, all that stuff. So let me show you the solution key now.
And how'd you know it was in that?
So I knew sine was positive. Sine's y over r. So that's why I'll give you that formula sheet, right? So you don't have to worry about that. Sine's y over r. R is always positive, so therefore y has to be positive too. If y over r is greater than 0. If y is positive, but tangent is y over x, right?
Yeah.
Y is positive, but y over x is less than 0. X has to be negative. Has to be. Yeah, I know it's mind bending. So yeah. And so once you get the right quadrant, you do the right triangle correctly, you just blast with the rest of these. It's right at the school to get. I did make a mistake with obviously it's all fixed and rescan. And lastly, for part C, secant. Secant is 1 over cosine theta or r over x. So r over x equals -3. And y over x is greater than 0 because tangent is y over x. We know this. If r is positive, x has to be negative. Do you see why x has to be negative? Right? X has to be negative if r is positive because r over x equals -3. Also, y is going to be negative as well. Because y over x is positive, greater than 0. That's negative y. Yeah. All right, let's focus. All right. So you're in Q3. You're in Q3. If you're in Q3, and so you're gonna say your R is 3 then, and your X is -1.
Why?
The reason why is that secant is 1 over cosine. So cosine theta is -1/3. And cosine X over R. Part C. Cosine X over R. Since cosine X over R. So the R is gonna be 3, the X will be -1. That's a 3 here. Therefore, that's root 8. If you back your thing correctly. But negative root 8, because pointing down. You could also simplify as -2 root 2, because 4 is a factor of 8. That's perfect square pulled out. You get -2 root 2. Once you have that, once you have the triangle set, then the rest of the problem's easy. But you can see it's a little bit of a brain power that's needed to make sense of all this, right? To know what quadrant in and draw the triangle correctly. And then once you have that all set, then you could just go through the rest. And did I make, gosh darn it, I made another mistake. Okay, I caught it myself this time. I have these swapped. My apologies. So what happens when you do this fast? You make mistakes. So yeah, so I'll fix this. That should be -1. So these are actually incorrect. I'll fix it. So oops. Yeah, I clearly messed that one up. All right, I'll fix that. Okay, last one. More unit circle stuff. Then we'll do the chapter review packet. All right, 2 pi over 3. So just look at your unit circle, right? Where's 2 pi over 3? It's right here. Where are the coordinates? Right there. -1/2 and root 3 over 2. Because it's unit circle, you're going to take the y coordinate. So the answer is root 3 over 2. That's all. By the way, the instructions said to use reference angles. You could, if you want to use reference. If you did reference angles, draw 2 pi over 3, which I know is 120 degrees. Same thing as 2 pi over 3. The reference angle is 60 degrees. If you remember your 60-90 ratios, if that were like 1, that would be 2, and that would be root 3, right? That's just how the ratios work. And since it's sine, opposite of hypotenuse, you get root 3 over 2. So when I do this without using the unit circle, that's how I'm thinking about just now. Ultimately, you're going to be at that point in a few months where you'll be able to do this without unit circle. But I do have this memorized, so if you have to memorize something, I have this memorized. It makes sense that it falls without your theorem, but but the root, knowing that this is half of this, I mean, that's something I memorize. But then if I just think about, okay, that's 120, reference angle 60, root 3 over 2, and of course, if it's cosine, I have to make x negative because you're in the second quadrant. So you could do that too, but for now, just reference your, no pun intended, but look at the unit circle. 7 pi over 6, right? 7 pi over 6, where's 7 pi over 6? Right here. Where are the coordinates? Right there. So 2 negative coordinates. One's root 3 over 2, one's 1/2. But both are negative. Both are negative. So you got negative root 3 over 2. And -1 over 2. Perfect. Cosecant is 1 over y. So -2. Boom, done. That's what you do there. Because cosecant is 1 over sine, right? So 1 over y. 7 pi over 4. Just locate it. 7 pi over 4. Right there. Coordinates right there. X is positive, y is negative, right? It's Q4. So you do that guy. So you get root 2 over 2, common negative root 2 over 2. Now tan is y over x. Y is tan y over x, because remember, that's r, that's x, that's y over x, right? So you got negative root 2 over 2 over root 2 over 2. That reduces to just negative 1. And lastly, for part D. Okay, now this one's not on the unit circle. I don't see negative 3 pi over 4. I don't see it. But I taught you guys that the other day, maybe we got to go clockwise. So if we go clockwise, only one of my fingers is off. Just negative 3 pi over 4. Negative 3 pi over 4. Do it again. Negative 3 pi over 4. If I was negative 135. So that's negative 90 so far. Yeah, I want those words. That's the check that I'm doing today is gonna be more of that kind of stuff.
How would you know that?
Well, for the angle's negative, right? So you have to go clockwise. So we'll do here. If it helps, you can convert that to degrees. But here's the thing: if you look at the unit circle, we do see 3 pi over 4. We see it up here.
Yeah.
But it's positive 3 pi over 4.
So it'd just be negative 135?
Exactly. So negative 135 means you have to go in the opposite direction.
But if it didn't have, like, let's say it didn't have 135 on there, how would you know that it had?
Let me do a wacky one with you. I'll do a wacky one. I know you're asking. So you have to be right there then. If you're negative 135. So you got those coordinates. Both are negative, and both are root 2 over 2. So you got this negative root 2 over 2, negative root 2 over 2. You want x, so negative root 2 over 2. There we go. Okay, let me give you a wacky one then. Let's say I got, I'm asking you to do sine of 17 pi over 6. Okay. If you think old school division, that goes in twice with a remainder of 5, like old school division, right? So that means that's going to be 2 pi plus 5 pi over 6. Well, 2 pi is 1 revolution, right? 2 pi is 1 revolution. So then you just do, are they playing Oklahoma State or Ohio State, Patrick? Ohio State? Oh, yeah, you guys lose.
Go Buckeyes.
They'll lose. Okay. Yeah. All right, 5 pi over 6. So that's going to be the coterminal angle. So you look at 5 pi over 6 right here. And if asking for a sine of 17 pi over 6, which is the same as sine of 5 pi over 6, because remember, I had to go around once and then stop here. I want the y coordinate, so that's just 1/2. That's how you would do that.
You find 5 pi over 6?
Right, because it says because 17 pi over 6 is not on the unit circle, right? Anything that's not on the unit circle, you're gonna have to figure out what you're gonna have to break down the fraction in such a way where you've got to take out at least 2 pi or take out 1 revolution.
They say 360 is 12 pi over 6.
Yeah, 360. Yeah, same thing. Yeah, you can do that.
You're like, you find 5 pi over 6.
Here, let's do another one. Let's do another one. So you develop more confidence with this. Let's say we've got tangent of 855. Okay, 855. Okay. So you can subtract 360, which will be 485. Wait, did I mess this one up? No, what am I doing wrong? Oh, 495. Yeah, that's 495. Subtract 360 again. That'll be 135. Okay, or just think about it. You go around once, go around twice, 720. 855 minus 720. That's the easy calculation to do more mentally. 135. Just right there. Use coordinates tangent y over x. You get -1. That's what you'd have to do. So you just got to keep. So that's why we learned that process of moving around the circle. Positive angles go counterclockwise. Negative angles go clockwise. All right. I think now we need to do some practice. I'm done talking. So let me stop the recording.